Alright guys, so now we're looking at a challenge problem here. So do your very best with this one. It is a little bit tricky and there's going to be two triangles and two equations. So the best thing you could do here is just to make sure you're keeping track of each triangle and each equation. So I'm going to try to break it down as simply as I can. But just try to do your best with this one. This is a challenging problem. Okay, so we've got two buildings are sited from atop of a 200-meter skyscraper. So it looks like we have a skyscraper. Let me go ahead and draw that out. It might look something like this. Right, so there's my skyscraper, and I have, let me draw some windows in it. You know, I like to draw some drawings out. So, oh, okay, I don't know what happened with that window. Alright, let's try that one again. Alright, perfect. So there's our skyscraper. This is a 200, has a height of 200 feet here. So this entire height here is 200 feet. So 200 feet. Okay, perfect. And it says that they noticed two other buildings, right? So I'm assuming they're all going to be on the ground. So there's some sort of ground level here. And the first building, let's just draw it having a height of that. And then the second one, we'll draw it having a height of that. There we go. So there's our two buildings. Let's call one A and let's call one B, right? So this is A, and then this one's going to be B here. It doesn't really matter. Okay, so building A is sited at a 35-degree angle of depression, while building B is sited at a 36-degree angle of depression. Okay, so for building A, we've got, so it looks like, so from the top of the building, it looks like maybe we're looking down at the floor of this building, right? So it looks like we're doing something like that. Okay, that looks good. So to building A, it says that this has an angle of depression, right? So that angle of depression is really important because that tells you that from the top, right? From the top, right, your horizontal is going straight. So your angle of depression is going to be the angle in between these. So in this case, this angle is going to be 35 degrees. 35 degrees. Try to make that a little bit nicer. Alright, so we've got 35 degrees here. Alright, for that whole thing. Okay, then it says to building B, it has an angle of depression of 36 degrees. So from here to the bottom of building B, so it'll look something like that. This guy has an angle of 36 degrees. So from the horizontal line all the way to that side, that is going to be 36 degrees. Okay, right? See how it's getting kind of tricky? Now we've got two triangles here. Okay, let's go ahead and identify these two triangles. So the first triangle we have is the one created with triangle A. So I'm just going to draw this line straight up. Right? There's our first triangle. And then our second one is the one that's created with triangle B. So draw a line straight up, and then there we go. So we've got two things we need to find here. Let's see. We want to find the distance between between the two, right? So we've got this piece right here. Let's call this piece right in between the two buildings. Let's call that piece X, right? And then we're gonna call this piece right here, from here to here, we're gonna call that piece Y. All right, so now let's go ahead and let's create our two equations. So our first equation, let's create it with out of triangle A here. Okay, so we know the height. The height is the same height as the building, which is 200 feet. So if we create an equation here, we can say the tangent of 35 degrees. All right, I'm only looking at the triangle in blue right now. The tangent of 35 degrees is equal to the opposite side, which is 200, over the adjacent side. So be careful here. The adjacent side is made up out of two values here. It's made up of the x value, and it's made up of the y value. All right, so this adjacent angle is actually made up of x plus y, and that's what makes this problem a little bit trickier. Okay, so we're going to leave that for now because there's no way we can solve an equation with two variables, right? We need to know some more information. So now let's look at triangle B. So for part B, right, we know the height. We know that this height is going to be 200 feet. We know the adjacent side is y, so we can again we can say tangent of 36 degrees is equal to the opposite side divided by that adjacent side y, right? In this case, it's just a y. All right, now we can go ahead and solve for a missing variable. I can actually solve for y right here. So that's what we're going to do. We're going to go ahead and solve for y. So I do 200 times 1, that gives me 200. Then I do y times the tangent of 36. Go ahead and divide by the tangent of 36. Divide by the tangent of 36, and I get 200 divided by the tangent of 36 degrees. That's going to give me 275. So y is going to equal to 275.276. Right, feet, right, of course. So that's feet. All right, but that's not what we're looking for. We're looking for the distance between the two. So I'm actually looking for x here. But in order to solve for x, I had to solve for y. So now all I'm going to do is plug y in. So we're going to end up getting, I got to cross multiply, right? So I get 200 is equal to x plus, instead of y, I'm going to plug in 275.276 times the tangent of 35, right? I'm just cross multiplying here. Kind of running out of space. 35 degrees. Now, we need to distribute here, right? I have to distribute whenever I have parentheses. So then this is going to end up giving me 200 equals x times the tangent of 35 plus 275.276 times the tangent of 35. So times the tangent of 35. And then I'm going to multiply the 275 times the tangent. So 275.276 times the tangent of 35. This is going to give me 192.75. I'm going to bring everything else down. Running out of space here, but it's okay. Bring down the 200. Okay, I'm gonna kind of scoot this over a little bit where we have some more room. So I've got 200 equals x times the tangent of 35 plus 192.750. And now I just got to solve for x. So subtract the 192 from each side. So minus 192.750 from each side. Oops, 750. Whoops, did that wrong. 200 minus 192.75. That gives me 7.25 is equal to x times the tangent of 35. And let's go ahead and divide by the tangent of 35. So let's divide by the tangent of 35 on each side. And now I get 10.35 feet. So they're about 10.35 feet away from each other. Okay. All right, well, there you guys go. You'll have one problem like this in your worksheet. Go ahead and look at the book. The book has some examples in section, I think it's 10.5, angles and this, 10.5 angles of elevation and depression. So if you need any help on this question.